SwayamPrabha. Digital India. Educated India.
Hello, welcome to lecture 28. In this lecture, we will be still dealing with shear flow in thin walled closed cross section beam. So, we will solve certain examples to have more understanding of the theory that we have discussed in the earlier lecture. So, the figure that I have drawn is that of a thin walled isosceles triangle. So, this distance are given as this is 39 t, because it is an isosceles triangle, this is also 39 t, and this is 36 t. This is 30 t. Now, C is the centroid. So, the centroid is 12 t and 24 t. So, we therefore, in summary, we have an isosceles triangle shown by the black color line. It has an uniform thickness of t. The angle theta that this portion 1, 2 makes with the x axis is given as, we can also find it. If we find it, we will see it is 22.62 degree. So, I have named the three vertices of the triangle as 1, 2 and C, 3 as it can be seen in the figure. A shear force F along the y direction is applied to the cross section or the beam through the shear center. So, this is the shear center of the cross section. Let us assume we do not know the shear center. Let us assume that the shear center is at a distance zeta from the 2, 3 web of the thin walled triangle. So, what we need to do is that we need to find the shear center of the thin walled cross section. So, this is the problem that we are planning to solve today. So, now as we can see that this cross section is symmetric about the x axis. So, we know that the shear center will lie on the axis of symmetry. So, the shear center will lie on the x axis, we just need to find out zeta. So, therefore, what we have done is that we have considered a shear force F along y direction at a distance zeta or through the shear center of the cross section. So, now, we can summarize that I x y of this cross section is going to be 0 due to symmetry. And then because we already know the position that the shear center is going to lie on the x axis, we do not need to apply Sx. So, Sx is equal to 0 and we have applied F in the y direction. So, Sy is equal to F. So, this is what we have. Now, if we substitute these conditions into equation 1, this equation 1 is going to simplify as S x equal to 0, I x y is equal to 0, S x equals to 0. Therefore, we are left with Q s minus Q 0 is going to be minus S y by I x x into T y, sorry I missed the T here, into T y d s, s varying from 0 to s. Since T is uniform, I can just write this as F T by I x x into 0 to s y d s. So, the expression for Shear's flow has changed considerably, and this is the expression that we have got. So, we can call it as 2. Now, therefore, we have figured out that the only sectional property that we need is I x x. So, let us try to find out I x x. So, I x x is going to be 1 by 12 30 t whole cube into t plus, because of the 2 inclined portion, we have 0 to 2 into 0 to 39 t, and then let us call this to be the s direction. This is the s direction. So, we can say that 2 y square dA 2 s sin square theta into dA is going to be ds into t. So, this is my elemental area. So, if I integrate this and plug in the value of theta as 22.62 degree, we can evaluate the value of I x x, which will be given as, if I calculate this, we will find that it is 8100 t to the power 4. So, that is the sectional property of the cross section, that only sectional property that we need. So, we let us now try to find out the shear flow in all the portions of the cross section. So, let us start by saying that Q1 is equal to Q0. So, we are assuming that the shear flow at point 1 is Q0. So, let us start with this. Let us start with this, saying that assuming or maybe we will move on to the previous page and erase this off, so that we have the figure. So, we know that finally, we have figured out that Q s minus Q 0 is going to be minus F t by I x x into y d s. Now, let us see. So, let us assume that Q1 is going to be Q0 or shear flow. So, Q1 is nothing but shear flow at 1. Now, once we have find out assumed Q1 to be Q0, we can find out shear flow in the entire cross section in terms of Q0. Now, let us start with for portion 1 2. Now, for portion 1 2, S is going to lie between 39 t to 0. Okay. And as we have given the direction of S, we will need to express y in terms of S. So, y can actually be written as S sin theta. So, when S is equal to 0, y is equal to 0, and when S is 39 t, y is equal to 15 t. Now, if we substitute that, then we can say q1 to S minus q1 is going to be minus f t by I x x into 0 to S sin theta into ds. Now, q1 is again assumed to be q0. So, this can be written as q1 to S is going to be q0 minus f t sin theta by I x x into S square by 2. So, this is one expression for the shear flow in portion 1 2. So, let me call it as A. Now, from this expression we can obtain Q2, which is going to be Q1 to 39 t, and that is going to be Q0 minus f t sin theta by I x x into 39 t whole square by 2. If we calculate this further, this ends up being q0 minus 292.5 f t cube by I x x. So, this is the q2 that we have. Now, let us move on to finding out for other portion. So, for portion 2, 3, what do we have? We have S varying between 30 t to 0, and y is going to be minus S plus 15 t. So, when S is equal to 0, y is 15 t, and when S is equal to minus 30 t, y is equal to minus 15 t. So, which is being satisfied. Therefore, we can say Q23S minus Q2 is going to be minus Ft by Ixx into 0 to S minus S plus 15t into ds. Now, if we evaluate this, we get Q23S as Q2 minus Ft by Ixx this is the expression we get. Now, from this expression we can get Q3, which is going to be Q23 30t. If we calculate that, that is going to be Q2, and this will end up being 0. So, we will have Q3 is going to be Q2. Q3 is going to be Q2, and Q23, the variation of shear flow, will be given by this expression. So, let us call this as P. Now, Q2 equals to Q3 is also justified physically, because it has a symmetry about the x axis. The shear flow at point 2 has to be exactly equal to the shear flow at point 3. Therefore, we get Q2 as Q3. So, once we have figured out that Q3 is equal to Q2, let us try to find it out for the portion 3(1). So, let me try to erase this, or let me go to the next page and try to find out for portion 3(1). So, for portion 3(1), S again lies between 39T to 0 and Y is going to be equal to plus S sin theta minus 15T. So, when S is equal to 0, Y is going to be equal to minus 15T, and when S is equal to 39, Y is going to be equal to 0. So, this seems to be okay. So, now I can say Q31S minus Q3 is going to be minus FT Now, Q3 is basically equal to Q2. Therefore, Q31S can actually be written as Q2, sorry, so this is another expression that we have. So, let me call this as C. Now, from this expression we can re-evaluate Q1, which is going to be Q31 39T. Now, if we evaluate this, we get this as Q2 minus FT by IXX into 39T whole square by 2 into sin theta minus 15T into sin into S into 39T. So, 39T into sin theta is going to give us 15T. So, therefore, we will get this as Q2 minus FT, and we are going to get this as plus FT because the minus will be there, F plus FT into, we are going to have this as 292.5 by IXX. If we calculate this, this is going to become into T square. So, this is going to become 292.5 T square. Now, this further can be written as Q0 minus 292. If we remember our previous expression, it is FT cube by IXX plus F plus 292 So, this and this cancels out. So, finally, we get Q1 is equal to Q0, or we get Q1 equals to Q0, the one that we had started with. So, this is a check to see that all the calculations have been done correctly. So, we go back to the same value that we had started with. So, this is what we get. Now, we have to find out the value of Q0. Now, to find out the value of Q0, we have to use Brett-Bethos theorem. So, let me just erase this off and say that we have found out Q1 is equal to Q0. Now, by using, so this is the next step of solving the problem. So, using Brett-Bethos theorem, okay. So, we can say that tau ds is going to be 0. Now, tau ds can actually be written as Qs by Ts into ds is equal to 0. Now, for this particular example, our thickness is uniform and that is equal to T. Therefore, we finally can say that Qs into ds is going to be equal to 0. Okay. So, this is the case only when the shear force is passing through the shear center, and therefore, there is no torsion in the cross section, and because there is no torsion, theta is equal to 0. So, let me write down, since the shear force applied shear force is F passes through the shear center, torsion is equal to 0, torsion is 0, and therefore, theta or the angle of torsion, rate of angle of twist is equal to 0, and that from this we get this expression that del Qs ds is equal to 0. Now, let us try to find out what is Qs ds for this particular problem. Now, Qs ds is equal to 0. So, let me find out what is Qs ds. So, now for portion 1, we have found out that Qs ds is going to be 0 to 39 T into Okay. So, this is for the portion 1, 2. Now, for the portion 2, 3, we will have 0 to 30 T, and then we are going to have Q 0 minus so, this is T square, sorry. And then we have minus This is for portion 2, 3. So, this is for portion 2, 3. Now, for portion 3, 1, we have 0 to 39 T into Q 2, which is going to be Q 0 minus and then we are going to have so this part is for portion 3, 1. Now, if we and that has to be equal to 0. Now, if we evaluate or simplify this expression, then we see that all these 3 integral has q 0 in them. So, q 0, so this can actually be written as q 0 into 2 into 39 T plus 30 T minus 2 into minus 292.5 F T cube by I x x into 30 T plus 39 T plus we have the integral which can be written as minus F T. So, this can actually be written as minus F T by I x x and that is equal to 0. Now, if we evaluate this, if we do this calculation, we can find out that q 0 is going to be, if we calculate everything, we will see that q 0 is going to be 0.213 F by T. So, from this expression, we can get q 0 as this. So, we now know the value of q 0. Now, let us try to find out the shear center. Now, how do we find out the shear center? So, let us take the moment about 1. If we take moment about 1, then the moment due to force F is going to be zeta plus 36 T, and that is going to be the moment 0 to 30 T q 23 s ds into 36 T. because if I draw the isosceles triangle and this is my point 1, this is F, this is Q 2 3, this is Q 1 2 and this is Q 3 1. Therefore, we can see that Q 2 3 is going to only Q 2 3 is going to produce a moment about 1. Q 1 3 and Q 3 1 and Q 1 2 passes through 2 and passes through point 1, and therefore, Q 1 2 and Q 3 2, Q 1 2 and Q 3 1 will not produce any moment about 1. So, they are not going to produce any moment about 1. So, we have to just evaluate the moment because of Q 2 3. Therefore, this is an example which shows that it is important to choose the point about which we are going to calculate the moment very carefully. Otherwise, we might get the correct result, we will get the correct result, but the calculations are going to become extremely tedious. Therefore, it is very important to wisely choose the point about which we are going to find out the So, this is how we have. So, this entire thing is moment due to Q 2 3 about 1. So, now you see that the sign of the moment because of F is negative of the sign of the moment because of the shear flow Q 2 3. Therefore, we have taken a negative sign on the right hand side. We have just multiplied it with minus 1, and if we calculate this in this equation, we will find out that zeta is going to be minus 10 t. Therefore, the shear center for the cross section will be, so the shear center for the cross section is going to be somewhere here. This is SC, which is at a distance of 10 t from the wall 1, 2 and 3. So, this is going to be the shear center of zeta. Okay. So, this is how we can find out the shear center of a given cross section. Thank you.